Your application gets to discover about launching, suspension, and resumption through the app class. Visual Studio's various Metro-style project templates all include a class called app, which derives from WinRT's application class, and there are various methods and events relating to the application lifecycle. For example, we can attach a handler to the suspending event. This event is our 5-second warning, so there are two important things we need to do in this handler. First, we need to ensure that the user's data is all safely written out to persistent storage. This model repository class is not a WinRT class. It's something I've added to this application. We'll be looking at how it stores data later on in this chapter, so I won't show the code inside this method just yet. Right now, I just want to show the best order in which to bring things to an orderly halt. The first job is to ensure that we've safely stored any data that the user wanted our application to remember. The second job is ensuring that any transient user interface state is also stored. For example, suppose your application supports two different views. When it first runs, maybe you show a list of items, and then maybe the user can enter a details view by tapping on one of those items. If your application happens to be in the details view for a particular item when it's suspended, you'll want to show the details for that same item when you come back. Or if the application is in the main list view and the user has scrolled to some particular location within that list, again, the application should show that same place when the user returns to the app. If you're suspended and then unsuspended, this happens automatically because your application state remains in memory. But if Windows decides to shut your process down entirely after suspending it, you'll have work to do in order to restore that state when your application is restarted. Microsoft refers to this transient state as session state. It's not as critical as the underlying data that your application handles. A user might be disappointed if the cursor is in a different place in some text box when they go back to your application, but they'll be a great deal more annoyed if you've lost text they'd already finished editing. So in the suspending event handler, we want to give priority to the user's data and only start on the session state once the important stuff is saved. Remember, we only get 5 seconds to do all of this, so we should do the most important work first, just in case the system is bogged down. So I'll use the C# await keyword, which means I'll also need to mark the whole method as async. And only when that first step is done do I use my session repository helper class to save out my session state. Both of these operations are asynchronous because both involve writing data out to the file system. That's a potentially slow operation, so we're not allowed to do that on the user interface thread. If I just invoked these two asynchronous methods without the await keyword, they'd run in parallel, and I don't want that. I shouldn't attempt to start writing out the less important session state until the user data is safely stored. Actually, there's another reason I mustn't just launch and leave these two pieces of work. I need to tell Windows when they're done. It turns out that if I just return from this handler, by default, Windows will assume that I'm ready to be suspended straight away. I won't get the whole 5 seconds I'm entitled to. That's a problem because this method will actually return before it's finished its work. If you're not familiar with how C# async and await keywords work, the Pluralsight on-demand library has a course dedicated to that very topic. But in short, when you use the await keyword, the method usually returns straight away, and the compiler effectively converts the remainder of the method into a callback that will run sometime later. So we have a problem. I've started the work to flush the user's information safely to disk, but this await keyword will return from this event handler, so Windows might suspend my process before I'm done. So I need to tell it that I've got work in progress. I can do that by asking this event argument for a deferral. Its suspending operation property offers a getDeferral method, which returns a suspending deferral object. Once the two steps for writing out my application's state are complete, I can call that deferral object's complete method to let Windows know that my application is now ready to be suspended, and if necessary, terminated. Just to be clear, this doesn't buy me any extra time. If I try to defer for longer than 5 seconds, I'll be suspended anyway. This is just to let Windows know if I'm ready ahead of time and equally to make sure that Windows doesn't think that I'm ready before I really am. Let's watch some of this in action. To begin with, I'll run the application outside of the debugger. It launches and I can interact with it. I'll now flip back to the desktop. If I open the Task Manager, you can see my application. And if we wait for a few seconds, it will eventually go into the suspended state. And there it goes. Now sometimes you'll want to be able to debug the code that runs during suspension. So I'll just kill that in the Task Manager so we can run it from Visual Studio. I'll set a breakpoint on my suspending event. This time I'll run with the debugger attached. My application launches once again, and when it's ready I can interact with it for a bit. And then I'll switch back to the desktop and go back to the Task Manager and wait for it to suspend. However, we're in for a long wait. Indefinitely long, in fact. It turns out that Visual Studio disables application suspension, and with good reason. Unless you have multiple monitors, switching back to Visual Studio will necessarily involve switching away from the application. And with the default suspension behavior in place, you'd only be able to spend 5 seconds debugging in Visual Studio before Windows suspended your app, which would be rather inconvenient. So to make debugging practical, Windows won't suspend an application that's being debugged. That's great, except for those occasions when the thing you wanted to debug was the code that runs during suspension. But they thought of that. Visual Studio's debug menu has a couple of entries designed for exactly this scenario. Trigger suspend kicks off the suspension process so that you can debug the code in your suspending event handler. And trigger resume will raise the resuming event that happens when Windows brings a process back out of suspension when the user switches back to it. So if I select trigger suspend, we'll hit the breakpoint on my suspending event handler, and if I wanted to, I could now trace through that. I'll stop debugging for now though, because I want to show some related events. As well as the suspending events, we could also handle the resuming event. Now, you might not need to do anything on resumption. Remember, this event means that although we were suspended, Windows didn't terminate our process, and now the user has switched back to our application, so we're back out of cryogenic suspension. It's still the same Windows process with the same stuff in memory, so everything will be exactly as it was before suspension. So in theory, you don't need to do anything to get the application back into its previous state. It's already there. The main purpose of this event is to let you refresh your status. If your application provides a view of some data fetched from the internet, such as the user's recent activity on a social networking site, it's quite possible that things have moved on since your application was suspended. If a couple of hours have passed, your application state will be out of date, so you'll want to fetch the most recent information. The appropriate code will vary from app to app. You might want to add some logic to detect just how out of date your current state is. If your application shows the weather, for example, you might decide that if you're only suspended for 10 minutes, there's no point in refreshing the data. If you've been suspended for an hour, then maybe you would fetch an update, but it'd be okay to show the previous weather data while you do that. And if you've been suspended for a day, then any information you may have had in memory from before is probably so out of date that you're just better off not showing it at all. But obviously this sort of application logic is specific to whatever your app does. In this demo, I just want to show you the underlying mechanisms that WinRT offers you, so I'm just going to leave this handler empty. So we've seen the events for transitioning back and forth between the suspended and running states, but what about when the application is terminated after suspension? Obviously, you don't get an event for that. Your application's suspended, so it can't run code, and Windows won't wake it before terminating it. That suspending event may be the last thing your code ever sees. However, the next time your app runs, it can find out whether it was terminated the last time it was running. The user might eventually return to your app after Windows decided to terminate it, and when that happens, Windows tells you through the event arguments it passes on launch. This argument offers a property called previous execution state. This tells you what the application's state was prior to launch. There are 4 possible outcomes defined by the application execution state enumeration. The very first time your application gets launched by any particular user, you'll see a not running state. The next one, running, implies that your application was already running at the point at which the user asked to launch it. There's more than one way to launch an app. Besides the start page, your application can opt in to being launched for search, sharing, or various other features, so you could well receive a launch request while already running. The suspended value would mean that prior to this launch, you'd been running and were then suspended, and then finally, the terminated value tells you that you had previously been terminated by Windows, so now would be a good time to recover your previous state.